Hey guys, this video is on linear systems of equations. The systems of equations that we're going to deal with are just going to be linear systems. So, in other words, we have two equations that both represent a line. Let me show you. Alright, so the three types of linear systems that we're going to see is an independent system. First of all, this is sort of what we consider to be normal because it does give us an answer. The solution to a system of linear equations is the point where the two lines that the equations represent intersect, so the point of intersection. You can solve linear systems by graphing. We won't be doing that because you have to have a fairly simple system to solve them graphically by hand using graph paper. You can solve more complicated ones using a calculator or a computer, but since those are not allowed on the final, we're not going to do any of them by graphing. But I did want you to see kind of what happens graphically to them because I think it helps you understand what it is you're looking for. So you are trying to find that point of intersection. So if it's an independent system, you will have that point of intersection. So here the answer would be the ordered pair that represents that point, which is going to be 7/5 and negative 11/5. If you're wondering where I got that, it's right there. It's kind of hard to see. That's why I wanted to rewrite it for you. Now, in the second one, you see a system of equations where both equations have the same slope. They are parallel to each other. That means they never cross. You will not find a point of intersection for these two equations. So what that gives us is no solution. We don't have a point of intersection, so there's no solution to the system. That's called an inconsistent system of equations, okay? And then our third type of system would be a dependent system. That happens when both equations actually represent the exact same line, so that when you graph them, you only have one line, okay? What happens with that is every single point, infinitely many points along that line, would be solutions to that system since they intersect everywhere. This little picture here is giving you two examples of possible solutions for that system. What we say usually is that that system has infinitely many or an infinite number of solutions. Now there is a way to write that as an ordered pair, but we're not going to be doing that. So if you see that, if you notice it in the textbook as you're reading through this section, you can just ignore the part where they give an actual ordered pair solutions for infinitely many solutions. Okay, we're going to take a look at two methods for solving. In this first video, we're going to look at solving by the method that's called substitution. In the second video, we'll go through a couple of problems where we solve by elimination by addition. And then in the last video, I'm going to show you an example of an inconsistent and a dependent system. An example of a system here. This is a system of equations. Notice that both equations have an x and a y variable. That's not necessary. You may have one equation that has two and then another equation that just has one. That is a possibility. But we solve systems that have two equations and two variables, two equations, two unknowns. You can solve systems that have any number of unknowns as long as you have at least that number of equations to work with. So let's take a look at solving systems of equations by substitution. Here are our steps that we will be using. The first step is to solve one equation for one variable. Substitution usually works best when that one variable has a coefficient of 1 or negative 1, okay? So we look for the variable with a coefficient of 1 or negative 1, okay? So that's pretty easy to spot in this particular problem. That's going to be that x right there, okay? It is a coefficient of positive 1. Substitution is a little bit more difficult to do if you don't have a variable that has a coefficient of 1 or negative 1. It will often create fractions and just be a little bit harder to work through. It's possible to use substitution on any system of linear equations. We use it beyond just linear equations as well, but It works best if you have a variable with a coefficient of 1 or -1. If you don't have that, you're probably going to want to use the second method that I'm going to show you in the next video, okay? Then we plug in what we get into the other equation and solve for the other variable. So you're going to take what you get when you solve for this one variable. You're going to plug that back into the other equation where you have that variable. Then you're going to solve what you get. It'll just be a regular linear equation with one variable. That'll give you one of your two answers that make up your ordered pair solution. Then you'll take that number, back substitute that value into either equation. It won't matter which one you pick, and then solve for the remaining variable. So let's check this out. It'll make a whole lot more sense if we're working through the problem while we're talking about what the steps are. So let me rewrite the problem. It's a little bit easier to see. Negative 5x plus 6y is equal to negative 19, and then x is equal to 4y plus 1. It's not necessary to put these in the same order for substitution. What we want to look for is the variable with a coefficient of 1 or -1. Then we want to solve for that variable. Well, in this case, I won't have to do that. X is already isolated on one side by itself, so I don't have to move anything. But if it were not, I would do that, okay? I would solve it for x. Then we take what x is equal to according to that equation, and we plug it back into the other equation where x is. So we're replacing x with 4y plus 1 plus 6y equals negative 19, okay? And then that is just a linear equation like we did at the beginning of the semester. You'll want to, not substitute, but it's, I'm stuck on substitute. You want to distribute the -5. That gives you negative 20y minus 5 plus 6y is equal to negative 19. Combine like terms and move constants to one side so that you can start isolating y. I've got two y terms here. Negative 20y plus 6y is going to give me negative 14y. Then we can go ahead and add 5 to both sides to move it over there with the negative 19. So if I do negative 19 plus 5, that gives me a negative 14 there. So y is equal to positive 1. That's half of our answer. These can be checked. By the way, once you find the full answer, you can plug your two numbers that you get, one for x, one for y, back into both equations and make sure that they satisfy both equations. If it does, then you have the correct answer. Now, what we'll do with this, we back substitute that value into either one of your two equations. I'm going to back substitute it in the one that's already solved for x, because that'll keep me from having to do any extra work as far as simplifying, moving terms around, that kind of thing. I just plug 1 in for y, and x works out to be 4 times 1 plus 1, which is 5. So I have a y value of 1 and x value of 5. Be real careful when you write the answer, because you want to be sure you do put it in xy form. And if you find y first and x second, like I did here, you may accidentally put them backwards. So just be careful about that. X is 5, y is 1. So that's our answer.